Mount Fuji is making a promise it has kept for thousands of years. And if it delivers, one of the world's largest cities will be brought to its knees. Right now, on the island of Honshu, a geological titan slumbers. It has been dormant for exactly 318 years, but before this long silence, it erupted on average every 30 years. The pressure is building. The timeline is stretched to its breaking point, and the 14 million people who live in its shadow are being warned that the greatest threat isn't the fire, it isn't the lava, it is the silence. A fine, dark, suffocating powder that will fall from the sky and paralyze everything it touches. The threat is so severe that in 2025, the Tokyo metropolitan government took a drastic step. They released a terrifying, hyper-realistic AI-generated simulation to shock a complacent public into action. But here's the part they didn't anticipate. Just months later, in May of 2026, scientists discovered the mountain was moving in ways they had never seen before. It was swelling, inflating on its own, and it had nothing to do with the magma stirring beneath. This raises a terrifying question. When a natural disaster is this overdue, is it still a surprise, or is it a certainty we refuse to confront? Let us know your thoughts in the comments below. We read every single one. And a quick urgent note. Our analytics show an incredible number of people watching right now are not subscribed. If you believe understanding these risks is important, take 1 second and hit the subscribe button. It's the only way to guarantee you won't miss our reports when they matter most. And it's the single best way to support this channel. It's a click that genuinely matters. Now, let's begin. Mount Fuji was not always a symbol of peace. Before it was a postcard, it was a predator. A composite of 3 separate volcanoes layered on top of each other over hundreds of thousands of years. The visible peak, the one we recognize, is called Shin Fuji, Young Fuji. It is just 10,000 years old. But buried deep beneath its symmetrical cone lie the remains of its ancestors. Ko-Fuji, or Old Fuji, and deeper still, Komatake, the ancient heart of the mountains. This geological trinity makes Fuji powerful, complex, and dangerously unpredictable. Its history is written not in years, but in eruptions. At least 180 of them in the last 5,600 years. A relentless cycle of destruction and rebirth. The ground at its base is paved with evidence. The Aokigahara forest, a dense sea of trees at the mountain's northwestern foot, grows on a floor of solid, hardened lava. A sprawling, uneven crust left behind by the massive Jogan eruption of 1864 AD. The mountain has always been active. The silence is the exception. The last time it broke that silence was December 16, 1707. What happened then is not just history. It is a blueprint. 49 days earlier, on October 28th, a colossal earthquake had ripped through the earth just off Japan's southern coast. The 8.6 magnitude Hoei earthquake, one of the largest in the nation's recorded history. It originated in the Nankai Trough, an underwater subduction zone where one tectonic plate grinds beneath another. The seismic waves were so powerful they were felt hundreds of kilometers away, deep underground. Beneath Mount Fuji, the planet's crust violently compressed. The magma chambers that fed the volcano were squeezed like a tube of toothpaste. For 49 days, the pressure grew. The invisible wound inflicted by the earthquake festered deep within the mountain. Then, the mountain answered. The Hoei eruption began without warning. It was not a gentle release of pressure. It was a violent, explosive outburst, classified as a VEI5 on the Volcanic Explosivity Index. A Plinian eruption, the most dangerous and powerful type. A column of ash, gas, and superheated rock blasted miles into the stratosphere. From a new crater that ripped open on the mountain's southeastern flank. The Hoei crater, the volcano disgorged an estimated 0.68 cubic kilometers of tephra, pumice, scoria, and ash. The material fell for days, for weeks. 100 kilometers to the northeast, the city of Edo, modern-day Tokyo, was plunged into darkness. At noon, the sky was pitch black. Terrified residents, under the reign of the Tokugawa shogun, Tsunayoshi, lit candles in the middle of the day just to see their own hands. Ash fell like silent gray snow. It accumulated everywhere, on rooftops, in the streets, across the vast agricultural fields that fed the capital. The layer grew to 8 centimeters deep in some parts of the city. A thick, heavy blanket of pulverized glass and rock, wooden structures, unable to bear the weight, began to collapse, rivers became clogged with gray slurry, their banks overflowing, triggering devastating floods and mudflows that buried entire villages downstream. The eruption officially ceased in February of 1708, but the true disaster was only just beginning. The ash had poisoned the soil. Crops failed across the entire region. The agricultural collapse led to a severe, widespread famine. Under Emperor Higashiyama, the nation watched as one of its most sacred landmarks became an agent of starvation and ruin. The story of 1707 is a historical blueprint for what could happen to modern Tokyo. If you live in a region with its own geologic or weather risks, tell us in the comments how your community prepares. The parallels are often startling. The memory of that event has faded into legend for most, but for volcanologists and disaster planners, it remains a terrifyingly relevant case study. Because the primary threat to Tokyo today is exactly the same as it was in 1707. Not fire, not lava, ash. And a modern metropolis is infinitely more fragile than the wooden city of Edo ever was. Our world is built on electricity, on transportation, on logistics, on systems that require near-perfect operating conditions to function, all of which are uniquely vulnerable to volcanic ash. People hear ash and think of soft, harmless soot from a fireplace. This is a profound and dangerous misunderstanding. Volcanic ash, or tephra, is not soft. It is rock, minerals, and volcanic glass pulverized into tiny, jagged particles, some smaller than a grain of sand. It is hard, it is abrasive, it does not dissolve in water, and when wet, it becomes conductive. It is a substance engineered by nature to destroy a modern city from the inside out. Let's start with the power grid. Tokyo is a city of 14 million people. It runs on a constant, uninterrupted flow of electricity. That flow is managed by a network of transformers and insulators. When volcanic ash, especially wet ash, coats these components, it creates electrical pathways where none should exist. It shorts out insulators. It causes transformers to arc and explode. The result is not a localized blackout. It is a cascading grid failure. Power stations would be forced to shut down to prevent catastrophic damage, plunging entire sectors of the city into darkness. No lights, no refrigeration, no communication networks, no internet, no functioning hospitals. All from a fine layer of gray dust. Then comes transportation, the lifeblood of any city. Government simulations project that a worst-case eruption could blanket the greater Tokyo area in a layer of ash between 2 and 10 centimeters deep. That doesn't sound like much, but the physics are unforgiving. As little as 3 centimeters of wet ash on a paved surface creates a slippery, impassable sludge. It has the consistency of wet cement, but with the traction of black ice, two-wheel drive vehicles lose all grip. Emergency services, fire trucks, ambulances, supply convoys, halted. The logistical network that feeds, powers, and sustains 14 million people would be severed. Trains, the backbone of Tokyo's transit system, would fare no better. The ash is highly abrasive. It would grind away at moving parts. It would clog signals. It would short out the electric third rails. The entire network would shut down, not for hours, but for days or weeks, until every inch of track could be meticulously cleared. Airports would be closed indefinitely. A single jet engine ingesting volcanic ash can be destroyed in seconds, the glass particles melting and fusing to the turbine blades. Tokyo would become an isolated island. The level of detail in these government plans is staggering and almost completely unknown to the public. If you found this breakdown of the ash threat valuable, please take a moment to hit the like button. And if you have family or friends who think a Fuji eruption is just about lava, share this video with them. Understanding the real threat is the first step. The numbers published by Japan's Central Disaster Management Council in 2020 are difficult to comprehend. A major eruption, lasting 15 days, is projected to dump up to 120 million cubic meters of ash on the greater Tokyo area. That is 2.5 times the entire volume of debris generated by the 2011 Tohoku tsunami. The cleanup from that event took years. This would be worse. It raises a question so immense it borders on the absurd. Where would they even put it? A city as dense as Tokyo has no space to store 120 million cubic meters of hazardous material. Officials have floated desperate ideas, including the mass dumping of the ash directly into the ocean, an ecological disaster in its own right. There is no good solution. This is the scenario that keeps disaster planners awake at night. A quiet catastrophe. A city of millions slowly choked into submission, not by a towering inferno, but by a silent, steady fall of abrasive, conductive, inescapable gray dust. A city that starves, not because food doesn't exist, but because it cannot be delivered. A city that goes dark, not because power plants have failed, but because the lines that carry the power have been defeated by a thin layer of powder. And the man who understands this threat better than almost anyone has a simple, chilling warning. His name is Toshitsugu Fuji. He is a professor emeritus at the University of Tokyo and the director of the Mount Fuji Research Institute in Yamanashi Prefecture. He is one of the world's leading authorities on this specific volcano. And his assessment is stark. He says, Mount Fuji has historically erupted every 30 years on average, but it has been quiet for more than 300 years now. It would not be strange if an eruption were to occur at any time. Let that sink in. A 30-year average, 318 years of silence. The mountain is not just dormant, it is overdue. By a factor of 10, imagine a pressure cooker left on the stove for 10 times longer than the recipe calls for. This is the statistical reality that volcanologists are staring at. Each passing year adds to the accumulated pressure. Each seismic tremor in the region is a potential sign that the system is reawakening. Professor Toshiyasu Nagao from Tokai University has publicly noted that seismic activity around Mount Fuji has increased. He warns of strong internal pressure building up inside the volcano's magma chambers. The mountain is not inert. It is a living, breathing system that is storing up enormous energy. The Japan Meteorological Agency, or JMA, continuously monitors the volcano with an array of seismometers, GPS stations, and thermal cameras. Currently, they have Mount Fuji at Volcanic Alert Level 1, the lowest level. It is officially designated as normal. But normal in this context is a dangerously misleading word. Normal simply means there are no signs of an imminent eruption, one that is likely to occur within hours or days. It does not mean the volcano is safe. It does not mean the pressure Professor Nagao mentioned isn't building. It just means the cap is still on the bottle. For now. This is the delicate state of existence for a region living in the shadow of a geological time bomb. The silence is not reassurance. The silence is the suspense. The Japanese government is not idle, but their actions reveal a deep-seated anxiety about public complacency. For decades, the image of Fuji has been one of serene beauty, not of imminent threat. How do you convince millions of people to prepare for a disaster that hasn't happened in over 3 centuries? In 2025, the Tokyo metropolitan government decided the answer was to abandon subtlety. They started by aggressively overhauling the Tokyo Regional Disaster Prevention Plan Volcano Edition. This wasn't just a paper exercise. They developed specific concrete protocols. They mandated the deployment of specialized vehicles, road sweepers, and wheel loaders, outlining the exact routes they would need to clear first to maintain access for emergency services. They issued new guidelines to the public, urging every household to stockpile at least a week's worth of canned food, bottled water, protective goggles, and dust masks. They even issued a chillingly specific directive on roof collapse. Residents are instructed to shelter in place unless the ash depth exceeds 30 centimeters, the point at which the weight becomes critical for standard wooden structures. It is a calculus of survival, weighing the risk of suffocation indoors against the danger of a collapsed roof. But the most dramatic move came on August 22, 2025. Concerned that paper warnings were being ignored, Tokyo authorities released a hyper-realistic, AI-generated disaster simulation video. The video went viral. It depicted exactly what their models predicted. It showed the iconic Tokyo skyline under a bruised, orange-brown sky. It showed the silent, relentless fall of black ash. It showed trains stalled on bridges over the Sumida River. It showed highways clogged with abandoned cars, their tires spinning uselessly in the gray sludge. It showed the city's lights flickering, then dying, plunging block after block into an unnatural darkness. It was a digital ghost story, a vision of the immediate future designed to scare a modern, sophisticated population into taking a primitive threat seriously. And I know we've asked once, but it's that important. If you've been watching this long, you clearly find this subject as critical as we do. It's easy to get engrossed in the story and forget, so please, if you haven't already, take this moment to subscribe. We'll try not to ask again, but the mountain might not be so patient. The AI video campaign was controversial. Some experts, like Kimiro Meguro, a professor of disaster mitigation engineering at the University of Tokyo, criticized it as alarmist. He argued, The simulation that is being shown would only ever happen under special conditions, and this is not a high probability event. He suggested that officials might be overcompensating, afraid of being accused of not providing enough warnings. It's a valid criticism. Is it more effective to show the absolute worst-case scenario even if it's unlikely, or does that risk desensitizing the public, making them dismiss the entire threat as fantasy? The Tokyo government gambled that fear was a more potent motivator than calm reassurance. The campaign forced the topic of a Fuji eruption into global headlines, but it also highlighted the deep uncertainty at the heart of the problem. No one knows if the next eruption will be a small burp or a Hoei-scale catastrophe. The government is forced to plan for the latter, even as critics accuse them of crying wolf. Then, just as the debate over the government's fear tactics was peaking, the mountain itself threw everyone a curveball. The science of volcanology for decades had relied on a key indicator to forecast eruptions: ground deformation. As magma rises from deep within the earth and pushes its way into the chambers beneath a volcano, it physically shoves the ground upward. Satellites and sensitive GPS stations can detect this swelling, or inflation, sometimes measuring just millimeters of uplift. This ground swelling is one of the most reliable precursors to an eruption. It's a sign that the volcano is loading its weapon. Fuji's monitors watched for this signal obsessively. In May of 2026, a team of scientists, led by Shuo Zheng, a hydrological geodesist at Hong Kong Polytechnic University, published a stunning paper in the journal Geology. His team hadn't been looking at magma. They had been looking at weather. They mined years of daily GPS data from 2017 to 2023, cross-referencing it with meteorological records. And they found something that no one had fully accounted for. Mount Fuji breathes with the rain. They discovered that during periods of intense rainfall, when tens of millimeters of water fall per day, the mountain's surface physically inflates by as much as 1 to 2 centimeters. The porous volcanic rock that forms the mountain's massive cone acts like a gargantuan sponge. As it absorbs thousands of tons of water, it visibly swells. Then, as the water percolates deeper or evaporates, the mountain exhales, contracting back to its baseline. This phenomenon, this rain-induced inflation, perfectly mimics the most feared warning sign of a pending eruption. The discovery was a bombshell for the monitoring community. It meant that a typhoon might produce the exact same ground deformation signal as a surge of rising magma. The clearest warning sign they had was now contaminated with noise. Sifting the signal from the noise, distinguishing a weather event from a geological one, suddenly made the task of forecasting an eruption infinitely more complex. The mountain that everyone was watching had just learned a new way to hide its intentions. It created a dangerous new possibility, that a genuine magma-induced swelling could be mistaken for a simple storm, a fatal misinterpretation that could cost thousands of lives. The watchers at the JMA now have to filter their data through a new lens, constantly asking if the mountain is swelling because it is about to erupt, or simply because it is raining. All right, I promise, this is the last time. But you made it this far. You're basically part of the research team now. We're a small channel tackling huge subjects, and every single subscriber makes a difference. So if you're still with us, you know what to do. Your support is what makes these deep dives possible. This brings us to the final, and perhaps most terrifying, piece of the puzzle: the trigger. Volcanoes do not exist in a vacuum. Mount Fuji sits at a nexus of extreme tectonic activity, a place where 3 of the planet's major plates, the Philippine Sea Plate, the Eurasian Plate, and the North American Plate, all converge and collide. This geological junction is what created the volcano in the first place, and it may be what determines its end. We have to go back to 1707. The Hoei eruption was not a random isolated event. It was directly triggered by the 8.6 magnitude Hoei earthquake 49 days prior. The earthquake acted as the detonator. Today, seismologists in Japan are not just watching Mount Fuji. They are watching the same place that earthquake was born, the Nankai Trough. This submarine fault line runs for hundreds of kilometers off Japan's southern coast, and it is building stress. Scientists are in near unanimous agreement that a big one, another megathrust earthquake of magnitude 8.0 or higher, is not a question of if, but when. Projections suggest a 70% to 80% chance of such an event occurring in the next 30 years. This is the ultimate tandem threat. A Nankai Trough earthquake would be a catastrophe in its own right, generating a devastating tsunami and severe shaking across a wide swath of the country. But for Fuji, it could be the uncorking event. Just as in 1707, the violent seismic waves could compress the magma chambers that have been slowly refilling for 318 years, providing the final violent squeeze needed to initiate a cataclysmic eruption. The two doomsday clocks are ticking in synchronization. The question is no longer just, when will Fuji erupt? The question is, will the next great earthquake wake the sleeping giant? This is the precipice on which modern Japan stands. A nation of unparalleled technological achievement, of meticulous planning, a culture of profound resilience. And yet it remains fundamentally at the mercy of forces that operate on a scale that dwarfs human engineering. They have a plan. They have a playbook. They have AI simulations and stockpiles of masks and specialized trucks ready to be deployed. They have scientists watching every tremor, every puff of gas, every centimeter of ground deformation, now struggling to distinguish the rain from the fire. But the mountain is a sovereign entity. It is a composite of 3 volcanoes fueled by the collision of tectonic plates. It has a history of erupting, on average every 30 years. It has been silent for 318. The plans are a response to an overwhelming geological reality. A reality that says the pressure is building. A reality that says the historical trigger is poised to strike again. The government is trying to prepare a city of 14 million people for a silent, choking darkness that last fell 3 centuries ago. They are trying to solve an equation where the variables are measured in millennia and the consequences are measured in human lives. The warnings are there, the science is getting clearer and in some ways more confusing, and the mountain sits in the center of it all, a perfect symmetrical cone against the sky. Serene, powerful, and waiting. The world watches the steam,